This is a quick introduction or review of factoring a polynomial using synthetic division. People first learn about this usually in pre-calculus class, and then sometimes it comes up in later classes, and sometimes people can't remember how to do it. So if we had a problem like f of x is equal to x to the third power minus 7x plus 6, we can use a process called synthetic division to figure out how to factor it if it's factorable. To get it in, well, I've put an empty pattern here that's used to fill out in order to carry out the process called synthetic division. And it's easier to fill out these numbers if we have all of the powers of x shown, including missing powers of x. In this case, there was no x squared in the original problem. So I created a term that is basically equal to 0. But if we write it as 0x squared, then we can see that the coefficients on this polynomial are going to be 1 on the x to the third power, 0 on x to the second power, negative 7 on x to the first power, and positive 6 for the constant. Now, to get the process going, most pre-calculus books today, and for the past several decades, have shown that you can use a graphing calculator to figure out what values of x would make this polynomial equal 0. Those are called the zeros of the polynomial, but generally the numbers aren't 0. In this case, if we take a look at the sort of graph that you might get, we see that this thing has a y value of 0 at negative 3, but also at 1 and at 2. So I think that I'll try to get this process going here by writing down f of x is equal to x cubed minus 7x plus 6, which is 1x cubed plus 0x squared minus 7x plus 6. Now the idea is that there's a first row, a second row, and a third row to the work we do in synthetic division. On this first row, the upper right corner is going to be a place to put one of the zeros that you choose. So for example, since we have a choice of zeros of negative 3 and 1 and 2, I think I'll choose the 1. But you could have picked any of those. I'll put a 1 here. And the rest of this row is left for the coefficients on the polynomial that you're trying to divide using synthetic division. So I'll fill in a 1 and a 0 and a negative 7 and a positive 6. Now the second line is where you do some scratch work that's part of the process. And on the third line you get the results of your synthetic division. And also at the very end there's a remainder box. So if you can imagine there being a last column, they usually will draw a solid line here lined up with that 6. And this is the remainder. If we get a 0 for the remainder, that means that the binomial factor that this suggests divided into this perfectly. Now if you don't get a 0, that means this divides in here but not perfectly, and there's going to be a remainder term. The only rules to synthetic division are you add going vertically, then you multiply anything on the bottom row by diagonally by this upper left corner, and then the result of that goes in the next column on the second row. I know that sounds complicated, but it's pretty easy to do. Since there's no number below this 1, then 1 plus nothing is 1. And 1 times 1 is a 1, which we can then write here. And that's the process. You just keep doing that until you get a result in the lower right corner. So when we do 0 plus 1, because we're going vertically, we get a 1. And when we multiply the upper left corner by this 1, we get 1 times 1 is 1 again. So I put a 1 on the second row in the next column. Now negative 7 plus 1 would make negative 6. and positive 1 times negative 6 is negative 6. And when we add these together, we get 0. So there really is a 0 remainder. So we can see here that in this process, we can take the coefficients from x cubed plus 0x squared minus 7x plus 6 and write them on the first line. We can write our chosen 0, and we had several to choose from, but I just chose this one. And we put that in the upper left corner. We do 1 plus nothing is 1, then we do 1 times 1 is 1, and it will go right here below the 0. When we add the 0 plus the 1, we'll get a 1, and we'll put that there. When we multiply the upper left corner by this one, we get a 1, and we'll put it here. And when we add here, we get a negative 6. And when we do 1 times negative 6, we get a negative 6, and I put it here. And when I add 6 plus negative 6, I get 0. And that means that we have no remainder. Now, the question is, how can you interpret this? Well, this is the remainder position here. This will be the ones place. This will be x to the first power, and this will be x to the second power. So this is suggesting something like 1x squared plus 1x minus 6. And the meaning of this 1 is that there must have been a binomial involved where if you plug a 1 in, you get a 0. And the rule for that is if this is called a, then you would use x minus a. But in this case, a is 1, so we'll really use x minus 1. So it looks like we're starting to get a result here, where f of x would be x minus 1 multiplied by x squared plus x minus 6. Now it is possible to continue to do synthetic division on the 1, 1, negative 6 as a new problem. You could try the 1 again, but in this case I don't think it would work. But if you go back to the graph, you could have used the 2 or the negative 3. But there's no need to do synthetic division once you hit a quadratic form. You can either use the quadratic formula, or sometimes these are factorable. I think if you take that off to the side and try to figure out factors of negative 6 that would add up to be a positive 1, you can get positive 3 and negative 2. So that means it's factorable, and we could have an x minus 2 times an x plus 3. So our interpretation first would be to say that the 1 in the upper left suggests an x minus 1 factor, and the 1, 1, negative 6 for the result of our division suggests 1x squared plus 1x minus 6. And then we can factor x squared plus x minus 6 and get, well, we can bring down the x minus 1, but we get from this trinomial 2 binomials, x plus 3, x minus 2. Oof. These can get much longer and much more difficult with higher powers of x, but this was just meant to be a review or a quick introduction. I hope you found that helpful. If you'd like to thank me by making a donation to my PayPal account, I've provided a link below the video in the description. If you're interested in hiring me for an appointment, or visiting my live stream where you can get help with a single problem at a time instead of hiring me for an entire hour at a time, my Twitch page is located at the link provided in the description below the video, as well as my Facebook page. Information about prices, including the amount that I charge per hour and group rates, and also the amount that I charge per problem and the live streams, is provided at those locations. To actually schedule an appointment, you can contact me directly by email. And I thank you for watching the video.